Hi everyone, welcome to this video where we are going to discuss the problem diagonal sum 2. So we will be discussing this problem in two parts. We will discuss about milestone 1, 2 and 3 where we will understand the problem statement, where we will come up with an approach in order to solve this, and then we will also write the instruction manual, that is the pseudo code. And once we are done with it, in the next part, we will be discussing milestone 4 and 5 where we will write the code using the instruction manual. So let's just directly jump onto the first part, which is the problem statement. Given a square matrix MAT, return the sum of the diagonal elements, sum of the all the elements along the diagonal. And matrix is given, as you can see, is a square matrix. That is, the number of rows and the number of columns in the matrix will be equal. Only include the sum of all elements on the primary diagonal and all elements on the secondary diagonal that are not part of the primary diagonal. But now the point is, what is the primary diagonal? What is the secondary diagonal? So for that, there is a sample input given. Input format will be n, representing the size of matrix n cross n, that is number of rows, number of columns, both will be n. And output should be the single integer sum, representing sum of all elements on both the diagonals, primary as well as secondary. So if there is 3 rows, 3 columns for this matrix having values 1, 2, 3, 4, 5, 6, 7, 8, 9, what will be the primary diagonal? The primary diagonal will be the values, the diagonal with having values 1, 5, and 9. And what will be the secondary diagonal? The secondary diagonal will be having values 2, 5, and 7. So this is primary diagonal, this is secondary diagonal. And in the problem description, it was mentioned, in the secondary diagonal, don't take the elements that are part of primary. That is, if let's say some element 5 is a part of primary diagonal as well as secondary diagonal, I do not have to take it twice. I have to only take it once. So what will be the output? The output will be 1 plus 5 plus 9 plus 2 plus 7. Actually, not 2 plus 7, but 3 plus 7. And do not include 5 again. So overall, the sum will be 1 plus 5 plus 9 plus 3 plus 7, which is 25. And it is mentioned in the note that element matrix of 1 comma 1 that is having value 5 is counted only once. Do not take it twice because it is present twice in the diagonal. No. If it is present in both the diagonals, still take it once only. So that corner case we have to keep in mind. We have to figure out that what all types of matrix will have this kind of corner case. But before that, actually, let's try to have some more test cases to understand the problem statement more clearly. So constraints, as you can see, is both the rows and columns will be equal because it is a square matrix, which will be from 1 to 100. Number of squares, the number of rows, number of columns in the square matrix will be from 1 to 100. At least 1 row, 1 column, maximum 100 rows, 100 columns. And all the values will also be from 1 to 100. So the point is how we can actually solve this. First, let's take the same test case. Let's try to figure out the indices which are getting as a part of any of the diagonals. What all indices are part of the primary diagonal? What all indices are part of the secondary diagonal? So if I will mark the primary diagonal, what are the indices? Can I say this element is present at 0th comma 0th index, 0th row, 0th column? This element is present at the first row, first column. This element is present at the second row, second column. But what about the secondary diagonal? If I will mark the secondary diagonal, this all values which I am marking in yellow are part of secondary diagonal. What are the indices? This is nothing but 0th index as row, second index as column. This is again first index comma first index, that is 1 comma 1, and this is 2 comma 0. So if I am first of all figuring out what is the property for rows, I can clearly see for the primary diagonal, the row is getting plus plus only. That is from 0th row to first row to second row is getting plus plus. In fact, for the secondary diagonal also, 0th row, first row, second row will become plus plus. But how about the columns? For the primary diagonal, the columns are also becoming plus plus, going from 0 to 1 to 2. Actually, both row and column are same only. If row is 0, column is also 0. Row is 1, column is also 1. Row is 2, column is also 2. So we do not need to run a nested loop for both rows and columns. We can run a single loop where both row and column will become plus plus. Row will also become 0 to 1. Column will also become 0 to 1. Row will also become 1 to 2. Column will also become 1 to 2. So when it comes to the primary diagonal, the clear property is the primary diagonal is, let's say, I comma I, where the row as well as column is same. But when it comes to the secondary diagonal, that is the yellow diagonal which I have marked, we can see it is starting from the top right corner. Top right corner means 0th row only, but right corner, that is the last column. So it is starting from, if I am saying 0, then the column will be n minus 1. That is the last column. If the row will be 1, what will be the column? The column will be actually, let me mark it in maybe yellow only. So if this is 0 comma 2, which is 0 comma n minus 1, this is 1 comma n minus 2. Like we are doing column minus minus at this time, from second column going to first column. And then again, we will be basically doing column minus minus. This will be n minus 3, or you can say 3 minus 3, which is 0. So for the secondary diagonal, row plus plus, but column minus minus, starting from 0 comma n minus 1. For primary diagonal, row will also become plus plus, column will also become plus plus, starting from both as a 0. And we have to run a single loop for the primary diagonal, a single loop for the secondary diagonal. The only point is, don't take this element twice. So when we are running the loop for secondary diagonal, if the element is also a part of primary diagonal, how we can check whether it is part of primary diagonal? If row will be equal to column, then it is a primary diagonal element, 0, 0, 1, 1, 2, 2. All elements apart from this in the secondary diagonal are not having row equal to column. So whichever element will have row equal to column in the secondary diagonal, it is also a part of primary. So don't include it in the secondary. So finally, what we will say, 1 for the primary diagonal, 1 plus 5 plus 9. But for the secondary diagonal, 3, is it also part of primary? No, row is not equal to column. So take 3 in the sum. Is 5 also part of primary? Is it already taken? Yes, row is equal to column. So do not take it twice. 7, is it part of primary diagonal also? No, row is not equal to column. So take it, because it is not taken yet. So answer will be whatever, 24 or 25, I guess. Yes. So this will be the output. But what will happen for a matrix where there are even a number of rows? This was a case where n was 3. What will happen for 4 rows, 4 columns? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then finally, the last row will be 13, 14, 15, 16. Let's assume this is the matrix. So in the primary diagonal, this will be the primary diagonal. How will it look like? Starting from top left to bottom right. And the secondary diagonal will be starting from top right going to bottom left. Is there any element which is occurring in both the diagonals this time? Actually, no. Primary diagonal is having 1, 6, 11, 16. Secondary diagonal is having 4, 7, 10, 13. This time, for 4 rows, 4 columns, there is no element which is occurring on both the diagonals, because intersection is in between the elements. So it might happen that there is no repeating element. So we have to not discard the repeating element if it is not there. But it might happen there is a repeating element. We have to discard it. So our algorithm should actually work for both kinds of test cases. So we have already discussed the approach, that is, do the primary diagonal, calculate the sum separately, calculate for the secondary diagonal separately. So we can do what? We can actually start writing the instruction manual. So for the diagonal sum, what we are saying, first of all, get the sum of primary diagonal from a function. We will try to write different methods, different functions for each concept or each diagonal. So get sum of primary diagonal by getting answer from by calling, let's say, primary sum. We are saying a function is primary sum and passing the matrix in it, because any function will require the matrix for which it can calculate the sum. And similarly, get the sum of secondary diagonal by calling the secondary sum. Let's say the function name is secondary sum. Secondary sum. This was primary sum. So we will be creating these two prototypes, these two function definitions. But whatever the sum of primary sum will be, let's say this is, we are going to do the sum of both the primary and secondary. So for that, we can actually maintain an answer variable. So initialize or maybe set integer answer as a 0. And then what? Do the sum of the primary diagonal in the answer. Add the sum in the answer. Add sum in the answer. And same goes for the secondary diagonal also. Add sum in the answer. And finally, we can return the answer, because that is what we need. So return the answer. But the point is how we can make both these diagonals, how we can calculate the sum of both these diagonals. For them, I am creating two functions. So static int, if I am writing in Java, although you can write the prototype in your language according to your needs. I'm just writing the prototype for now. This function will give me the primary diagonal sum, Similarly, there will be one more function which will give me the secondary diagonal sum. And these two functions together will give me the answer. So for primary diagonal, we are saying let's initialize the answer again because we have to take the sum of all values as 0. But for a primary diagonal, as discussed, the indices will go from 0, 0, 1, 1, 2, 2, 3, 3, and so on, top left to bottom right. So let's initialize, let's set row, the initial row as 0 as well as column as 0 because starting from 0, 0, 0, top right cell, top left cell actually. The top left cell is where from we will start from. And we will go to the bottom right by doing row plus plus as well as column plus plus. Till which point? Till we can say we are going out of the matrix. That is till the row becomes n. Zeroth row, first row, second row. If row becomes third row does not exist for a matrix having 3 rows, 3 columns. So as soon as the row becomes equal to n, we have to stop. So run a for loop or a while loop, anything. You can have a condition with condition what? With condition row should be less than n, where n is the number of rows. So let's initialize. Let's set n as the number of rows, as the number of rows in matrix. So you can use inbuilt functions in different languages to actually get the number of rows, or you can use some properties from a given matrix. But once we have figured out the number of rows, once we have initialized the answer, we have initialized row and column as 0, we will be running the loop as discussed till row is less than n, that is till the row is within the matrix. We will add the current value in the target, add the matrix value at the row comma column in the answer. And once we are able to add it, we will do what? For the primary diagonal, row will increment as well as column will increment. So row plus plus and column plus plus, both will become plus plus only. And once this loop is ending, we can just return the answer. That is what you have to do for primary diagonal. No need to check whether for now the limit is repeating or not, because repeating should be discarded. The repeating element should be discarded in the secondary sum, in the secondary diagonal. If a element is in a secondary diagonal is also a part of primary diagonal, do not take it. So let's copy all of these. We will do the changes accordingly. We will again have the number of rows as n. We will again initialize the answer as 0. But this time, row will be initially 0, starting from the top right corner. Column will not be 0. Column will be the last column. Column as n minus 1. And the while loop condition will be same. We will be going till the matrix. We are within the matrix, that is row is within n, less than n, row 0, row 1, row 2, because both the diagonals are going from top to down only. But add the matrix present at row comma column only if the element is not repeating. If row is the same as column, is equal to column, don't take it. If row is equal to column, just continue. Then continue. Continue means do not apply these two lines. Do not run these two lines. But row, as we discussed, will go top to bottom. But column will be going from right to left. That is, column will become minus minus. So these few changes were there for the secondary sum. So we have now actually completed the instruction manual. We will actually write the code of the problem diagonal sum 2 in different programming languages. And now we will be using Java language as a medium to write the code. So first of all, we will be saying just calculate the sum from two different diagonals. So let's try to have an answer variable which will give me the answer, which will help me to return the sum of both the diagonals. We are saying first make a call to the primary diagonal sum, that is by calling the function primary sum and passing the matrix in it. So we will be saying let's have the sum is equals to what? Is equals to primary sum, and we will be passing the matrix. Whatever sum is, let's first actually do this much code and print the sum to confirm whether we are getting the correct sum or not. And after printing sum, what we can do is we can for now return something, return 0 from the function, because there is a function with return type. Similarly here also, we will return 0 for now. We are not implementing secondary sum. Let's first try to implement the primary sum function, where we are setting n as what? As the number of rows in the matrix or number of columns, both are same. But how to get number of rows in Java? We can say int n is equals to mat dot length. Dot length is the property, or you can say length is the property which we can access to get the number of rows. Similarly, answer will also be set initially to 0 because sum will be taken starting from 0 only. And for the top left to bottom right diagonal, for the primary diagonal, row as well as column will start from 0. Once we have initialized all the required variables, now is the time to run a loop over the diagonal. That is, run a while loop till the point we are within the matrix, till the point row is less than n. Because as soon as we will go out of the matrix, we have to stop. We can't say that just take the element. Every time, just add the current element in the answer. So answer plus equals to the matrix of row comma column, matrix of square bracket row comma square bracket column. And since we are going from top left to bottom right, 0 0 1 1 2 2, row as well as column is becoming incremented by 1. So row plus plus as well as column plus plus. So for now, let's just return the answer and check whether the primary sum diagonal, that is the top left to bottom right diagonal, is working fine or not. Let's see if it is giving me the required sum. For this particular matrix, this is, if this is the input, output should be 1 plus 5, 6, 6 plus 9 as 14, 6 plus 9 as 15, actually not 14 but 15. So what we are getting as output, 15 is the output. Obviously, the final output is 0 because we are returning 0 in the last. That is what also getting printed. But primary sum is working absolutely fine. So we can do what? We can add in the answer. So just add the current sum in the answer. So we can actually write it in the one single line only. Instead of writing first take the sum and then add that sum, we can just directly say that whatever the primary sum will return me, I will add in the answer variable. Answer plus equal to primary sum. Let's do it for the secondary diagonal also. So for secondary diagonal, we will be making a function call the way we made it for the first diagonal. So let's say int sum is equals to secondary sum, and by passing the matrix, let's again just do the system.out.println to confirm whether the output we are getting is correct or not. Finally, this time we should, let's say we are returning answer, although we have not completed the code, because we should add the sum variable in the answer also. Anyways, we will again say int n is equals to mat dot length. That is the number of rows for the secondary diagonal also. Again, answer will initialize from 0. The sum initialize from 0. We will take the row as well as column as 0 and n minus 1 respectively initially, because we are starting from top right corner. The top row, last column. So 0th row, n minus 1th column. And this time the loop will be same because we are going from top to down only, row till it is less than n. We will run the loop, but few changes will be there. That is, we will add the value in the answer, add the matrix of row comma column in the answer. Row will still become plus plus, but column will become minus minus because we are going from right to left, last column till the first column, top right corner till the bottom right corner. So if I will not add this if condition, let's see what is happening. Let's just return the answer and see the answer. If I'm not discarding the element which is present in both the diagonals, what will be the answer? Let's see. We're taking some time to run and we are getting wrong output, obviously. But the output we are getting is 15. That is the second diagonal, the secondary diagonal. 3 plus 5 plus 7 is giving me actually 15. But this diagonal is also 15. This diagonal is also 15. I should not give the output as 15 plus 15, which is 30. I will have to take 15 plus only 10. The 5 element is present in both the diagonals. Do not take it twice. So that's why we are adding a if condition in the secondary case. That is, if row is the same as column, it means the element is in the primary diagonal also. Then do not take it. Continue. Just do not take it. We have to continue. And otherwise, we can say we have to basically write the answer plus is equals to matrix of row comma column. And actually, before writing continue, what we have to do is we have to do the row plus plus and column minus minus, because if we will simply continue, this loop will go into an infinite loop. So what we can do is we can just have, if row is not equal to column, then do the addition. Otherwise, don't do the addition. Otherwise, don't add the answer. So we can say like this: if row is not equal to column, then only add the answer. So we have slightly changed the logic so that the row plus plus and column minus minus happens even if row is equal to column. Otherwise, it will go into infinite loop. Let's just run the code and see if it is working fine or not. It is going to take some time to run. And this time it is actually giving me 10. That is, the secondary diagonal is excluding the element which was also present in primary diagonal 5. So now we can add the sum in the answer by directly just saying answer plus is equals to secondary sum, the same way which we did for primary, and finally return the answer. So if I will run the code, it should give me accepted also this time, because now we have not printed them separately, but printed them on one attempt only. So let's just submit it, and hopefully it should work for all the test cases. Let's see. It is taking some time, and let's see if it is going accepted or not. All the 15 test cases, the corner cases, everything is going perfect.